Hey guys, in this video we're going to start 7C.2. Our mastery learning objective is I can use the properties of a 30, 60, 90 triangle to solve for the missing sides. So again, 30, 60, 90, that references the angles within our triangle. And if you want to triple check, if we add these three angles, this does add up to 180. So similar to our 45, 45, 90 in our last video, this also has a little shortcut of what to set each side equal to solve for our missing sides of whatever triangle we have. One thing to keep in mind is that the hypotenuse is still going to be across from that 90-degree angle. All right, and then our 60 and our 30, what's important is that across from our 60-degree angle is going to be the longer side, right? Not as long as the hypotenuse, right? The hypotenuse is the longest side, but compared to the other two angles, across from the 60, because 60 is bigger than 30, that's going to give us our longer segment over here. Likewise, our shorter length is going to be across from the smaller angle here, which is going to give us this shorter side. Okay, so just keep that in mind. Again, the hypotenuse is the biggest one, but compared to the 30 and the 60, 60 is going to have a longer side than the one that's across from the 30-degree angle. So let's talk about what our theorem says. So across from the 90-degree angles gives us our hypotenuse, and the hypotenuse is always going to be 2 times A. Right? Our longer side, which is across from the 60, is going to be A times the square root of 3. And what's nice is that our shorter side is just going to be A. All right, so that's what we need to remember on a 30, 60, 90 triangle. Hypotenuse is going to be 2A, longer side is going to be A times the square root of 3, and the shorter side, which is across from the 30-degree angle, is just A. So that's what I'm going to be referencing throughout the whole video. So if you need that, you obviously won't be able to see it in the video, but you do have it at the top of your paper. All right, so looking at our directions here, it says find the value for the variable. We have a 30, 60, 90 triangle. So the first thing that I would do is start off with what we do have. What we do have is our hypotenuse, right? Because this would be our hypotenuse across from the 90. And our hypotenuse on a 30, 60 angle triangle is that hypotenuse equals 2A. So I'm going to start off with writing that and say that our hypotenuse is 2A, and 2A has to equal what my hypotenuse is, which was 6. Right? Hypotenuse needs to be 2A, but our hypotenuse in this example already tells us it's 6. So therefore, I just solve to get A by itself, which means I'm going to divide by 2 on each side. And A is going to equal 3. So I don't know what happened with my board here. Let me zoom back in. Okay, so from there, we're going to go ahead and figure out our other missing segment lengths. So therefore, if we know that A is equal to 3, what helps us out is that our shorter length, so the shorter length that's across from the 30, is A. So if this has to equal A, that means that X has to equal A. But we just said that A is 3. So I'm going to substitute that in here, which means that X is 3. All right, that's this missing side. Our W is across from the 60 degrees, and which is the longer side. So our longer side has to equal A times the square root of 3, which in this case is W, right? If we know that A is 3 though, I'm going to go ahead and substitute A in here, which would be 3 times the square root of 3, which is my W. All right, so again, you really just have to remember what each side has to equal. Start off with what you know in order to find the other missing sides, right? So looking at our second example here, I have a 30, 60, 90 triangle again, and I'm looking for S and T. And what they do give me is what is across from our 30-degree angle. Across from the 30-degree angle is our shorter side. This has to equal A. So what's nice is that, well, then A equals 2. All right, we already know that. Trying to figure out our other missing sides, I'm going to go ahead and find my longer side. So my longer side is across from the 60. So across from the 60, here's S. And that segment has to equal A times the square root of 3. So if I know A is 2, I'm going to go ahead and substitute that 2 in, which is going to be 2 times the square root of 3, and that's going to be my missing side for S. All right, so this would be 2 times the square root of 3. To find my hypotenuse is always across from the 90, which is T. And in this case, our hypotenuse always has to equal to A. I'm going to take that 2 again, substitute it in here, which would be 2 times 2. And our hypotenuse, oops, did I miss something? Yep, would be 2 times 2, which is 4. And this would be 4. All right, we have all of our missing sides. We can go ahead and move on to the next example. So looking at example number 3, we have a 30, 60, 90, and again, the reason why I know that it's 30, 60 is because this is 30, this one's 90, which means this one has to be 60. And across from that 60 degrees is y, across from the 30 is 2 times the square root of 3, and my hypotenuse is x. So again, start with what we know, which is across from my 30 is 2 times the square root of 3. Across from your 30 is equal to a. So therefore, a in this case is going to be 2 times the square root of 3. All right, I'm going to use that to find my other missing sides. My y is across from my 60. So y has to equal the longer length, which is going to be a times the square root of 3. But since this whole thing is a, I'm going to substitute that in for a. So that would be 2 times the square root of 3, but times the square root of 3, right? Because a, just to kind of show you what I'm talking about, this whole thing was a. So that's what a is. I still had that extra square root of 3, so that's why you see 2 of them right there in our problem. So now we simplify this, right? This would be 2. We can combine the 3 and 3 under the same radical, which would be 2 times the square root of 9. And then always check our square roots. Remember, you can check the square root. Square root of 9 is 3, which would be 2 times 3, which is 6. So y simplifies all the way to the answer 6. So this is going to equal 6. Our hypotenuse is across from our 90-degree angle, which is going to equal 2a. So if 2a equals our hypotenuse was x. We know that our a, though, was 2 times the square root of 3. So therefore, this is going to be 2 times the square root of 3, which equals x. 2 times 2 is 4 times the square root of 3, which is my hypotenuse. All right, there is no square root of 3, so I just leave that as my answer. All right, last example here, I have a 90, 60, and we obviously need to know that the missing angle to add up to 30 or 180 degrees is 30. I start off with what I do know, which is the longer side, right? That's across from the 60 degrees. That would be that my longer side, which is a times the square root of 3, has to equal what it says is there, which is 5 times the square root of 2. All right, we want to solve for a. So therefore, we're going to do the opposite operation. So instead of multiplying by the square root of 3, we're going to divide by the square root of 3. And that's going to give us our longer segment length to be a equaling 5 times the square root of 2 over the square root of 3. We just leave our answers as improper fractions like that. We don't have to worry about rationalizing. You can just leave your answer like that for this activity. So that's what a is. Across from my 30-degree angle is x, but x has to equal a. If we just said that a is 5 times the square root of 2 over square root of 3, that would be my final answer. So again, this is a 5, not a 6. All right. My hypotenuse then is the last segment I have to solve for, and that has to be 2 times a. So that means y has to equal 2 times a. My a, though, was 5 times the square root of 2 over square root of 3. When I multiply, I'm going to multiply my coefficients there. So 2 times 5, right? 2 times 5 is 10 times square root of 2, still over the square root of 3, which would be my hypotenuse, and the last side I need to solve for. All right, that brings us to the end of this video. Again, the other thing just remember is the shortcuts. Remember what each side is equal to. Start off with what you know and then solve for your other missing two sides. Go ahead and work on activity 7C.2, and there is a mini quiz after this, so work on that as well. Good luck.